Today we're going to start let's expand this a bit. So far what we did were just simple arithmetic transformations, divide the dependent variable, divide the independent variable. Just take note that the effect on the coefficients will be different. So if it's the dependent variable who's being transformed, let's say you're dividing it, no? I-divide natin siya, then the effect on the coefficients of all the independent variables will be also divided by 16. On the other hand, if a particular independent variable is transformed, okay, that particular independent variable will also change. Notice that when we are changing only a particular variable, it is that particular variable will only change. The others will not. No? And if we're dividing the variable by 20, then its effect on the coefficient will be times 20. Or reverse, if we're multiplying the independent variable by 20, its effect on the coefficient will be divided by 20. Okay, so let's take a look now at another example of transformations ano natin, sa variable natin. Okay, we so sige, tingnan muna natin tong standardization. Coefficients. Okay, what do you mean by standardized coefficient? From your previous subjects in stat, you know that the value of a standard deviation, diba, is the variable minus the mean divided by, I'm sorry, how do we standardize a variable? Okay, it's my mistake. I said that the value of the standard deviation. How do we standardize a variable? So in order to normalize or standardize a variable, what do we do? If you recall from your stat note, C is equal to x minus the variable minus x mean, diba? If you recall this, divided by the standard deviation. So that's a normalized or standardized value. Now, sometimes you might be interested in just getting the coefficients of the standardized variables. So, ibig sabihin yung equation natin, ang gagawin natin dito, what we're going to do is that we're going to standardize yung birth weight, standardize yung cigarettes, standardize yung yung family income. So when we do that, when we standardize these values, okay, let me show that for a while. So family income, how do we standardize this? So this is 13 minus 5 divided by the average of all of this, divided 13 minus 5 minus the average of all of this, okay, divided by the standard deviation. Okay, so mathematically, how do we do that? So let's kunyari mean ng dot natin, and then dot yung family income. Okay, so you get the mean, that's 29.0266, no? And then you get the standard deviation of ganun din, si dot, and then family income. Ang standard deviation niya 18.73928. No? So in order to convert this into standardized figures, so yung 13.5 natin, ito, this one, and then we subtract the mean, which is this one, and then divide it by the standard deviation. So this is now the standardized value for the first item here, 13.5. Okay, and then you can compute now for the for the other values here. So the value that we're going to use for regression is these values, yung standardized values. So how do you interpret that pag standardized yung values natin? Okay, let's have an example and we're going to use another data set. Okay, let's use, gamitin ulit natin yung another data set dito. Let's call it dot one na lang, kanina dot alt minus. And then let's use the gamitin ulit natin si Wooldridge data. Okay, sa Wooldridge data, if you recall yesterday, last time, ilagay mo natin dito data sets na ito na lang. Diretsin ko na. Packages, Wooldridge. There are 115 data sets. No? Yeah. So, guys, those of you who do not have data yet, you can get data here. So let's use housing price. This actually is related to the model of the itong H price 2 ang gamitin natin. Ito. H price 2. So ito yung mga variables natin. Price, crime, NOx is nitric oxygen, rooms, distance. All right. Okay, so let's get this data. So how do we get data? If you recall, we use the data function hprice2, and then yung package natin, sabihin natin this is coming from Wooldridge. There. So let's get the data. You see hprice2. Natin. Okay. So these are the variables. This is the data. We're not going to use everything. Ano lang. This is just to illustrate yung paggamit ng standardized values. So if we're going to use standardized values, so let's call it mod underscore S lang for standardized. And same, we use LM. Okay. And then we don't need to convert dito sa data natin. Yung mga kunyari price, co-convert to standardized values. You don't have to insert in Excel, for example, the standardized value for price. No? Or in fact, in R also you can insert another column here, which is the computation for the normalized value ng price, which we know to be, for this observation, 24,000 minus the mean of price divided by the standard deviation of price. Okay, we don't need to do that because we can use, there's a function in R called scale. Sige, before we do that, tingnan muna natin class yung scale. So what does this do? Let's check. Okay, scale is from the base R, which means it comes in already included. All right, so what scale? Generic functions, default method, centers or scales, columns, or the numeric matrix. So in scale niya, okay, the default is ito. Okay, for scale, yan sabi dito, centers, okay? Centers or scales the columns of a numeric matrix. Sine-center niya. So ang default, center dyan, ibig sabihin, ima-minus yung mean. either a logical value or numeric like vector of length equal to the number of columns of X, where numeric alike means that as the numeric, okay, yan. So sinesenter niya, ibig sabihin, mina-minus niya yung ano yung standard deviation, yung mean, tapos kinukuha yung standard deviation. Okay, so let's use this. So what will happen to our, okay, so LM scale ni, let's use price. Si price natin yung ano natin, yung i-predict natin, price, and then i-regress natin. Okay, now for pag standardize yung mga coefficients natin, we will have to zero out the intercept. Sa ganun talaga kapag standardized, kasi the intercept is just a lone figure, no? So isi-zero out natin siya, and then we add the other variables that we're going to use. So sige, gamitin natin SINOX, yung nitric oxygen, just for purposes of example. And then let's use plus scale the crime. Tapos let's use also plus scale din natin si distance. And then let's also use scale ng ST ratio. Okay, just to go back. So H price natin. There's a variable here, yung ST ratio.
Average student-teacher ratio po siya, sir.
Average student-teacher ratio, no?
Yes, sir.
Hindi ko siya makita.
H price 3 po kayo ngayon, sir. H price 2 yung data.
Sorry. My bad. H price 3 pala yung natingnan ko. Yeah. Yung sa yung sa presence ng ilang teachers dun sa H price 2. So where is my ST ratio here? Yun. Average student-teacher ratio. Okay? So here, what we're doing is that we would like to generate a standardized na ang data natin, H price 2. We have to identify that. So gusto natin yung result will be standardized. Okay, model model standardized. We are regressing price, and si price naka-normalize din. Okay, scale, no? And then SINOX, nitric oxygen, ppm, parts per 100 million. And then si crime din, crime rate per capita. Distance is weighted distance to 5 employee centers, etc. Okay, so ito yung ito yung regression natin. All right, then summary natin si mod S. All right. So, how do we interpret this? Paano natin i-interpret kung standardized yung coefficients natin yan, scale, naka-scale siya? What do you think, class? Ano yung interpretation natin dito? Okay, pag naka-standardize yung figures natin, obviously the interpretation will be standard deviation din ang pagbasa dito. So for example, for every 1 standard deviation increase in NOx, there's a corresponding 0.512 standard deviations decrease in the price of the house. Okay? for every 1 standard deviation increase in the crime rate, there's a corresponding 0.16 standard deviations decrease in your housing price, ceteris paribus. Don't forget the ceteris paribus. So everything is interpreted in terms of standard deviations. Okay? So if you see something like that na naka-standardize yung figures, then you know what, you know how to interpret that. No? It should be interpreted in the light of standard deviations. Kasi everything is expressed in standard deviations. Okay. Any questions, guys? So I just wanted to make sure that you understand if you're seeing a table, for example, the results like this, where the beta coefficients, you're told that the beta coefficients are standardized values, then you know what, how to interpret it. This is interpreted in the light of since they're standardized values, we interpret that as standard deviations. Okay, so what about quadratics, yung squared, no? And polynomials. Sometimes you might encounter a model where which calls for a nonlinear model, kasi yung relation ni dependent at saka independent variable hindi talaga linear. It follows a quadratic curve or a polynomial. So pag ganun, class, if you're going to use LM, if you're going to use a linear model, then chances are your error terms would be very high. Chances are you'll have heteroscedastic error terms. Kasi hindi nakaka-capture yung nonlinear behavior ng data. Okay, so let's first learn how to. Okay, can you please repeat purpose? 0. Okay. Let's try. Okay, that's a good question. Thank you, Jaime, for that. What if we remove 0 here, class? What will happen? Okay, I remove 0, and let's run this. Okay, nagkaroon ng intercept, di ba? And the intercept is practically 0. Imagine 5.65, and you have 15 zeros and then 565. Yan, di ba? So even if I did not include the 0 there, you'll have a very insignificant, no? Insignificant intercept. Tapos practically 0 pa. Walang value to. Okay, kasi what happens, guys, when you standardize? Ano ba nangyayari when we standardize?
Difference po ng mean. Tapos, hindi ko sure, sir.
Yeah, how do we get the standardized? Di ba? We subtract the mean, right? Tama? And then we get divided by the standard deviation.
Yes po, sir.
Yeah, so what happens, guys? Ano mangyayari sa intercept natin pag ganun? Okay, so let me put it this way. Kasi pag nagsa-standardize tayo, we are removing all averages, no? Sa lahat ng data natin, we remove the averages. Yung intercept kasi, it's actually added to the average. Okay, and pag tinatanggal natin yung average, nawawala yung intercept. The intercept does not mean anything anymore. Kasi we are reducing our independent variables by the average, each one of them. Okay, so in fact, if we did not, we still get the same answer. We have a value of the intercept that's very, very, for all intents and purposes, it's 0. Okay, di ba? Tingnan nyo, guys, hindi natin linagay. Pero, ang lumabas, Tama, class? Kasi if we interpret this, kunyari, what's the meaning of the intercept here? It's the number of standard deviations of change in your price if all the independent variables are the standard deviation changes in your other variables are zero. So what's this? Ilang standard deviations to? Zero din yan. Di ba? Kasi 5.65 times 10 to the negative 16. So it's just the same. Ako ay dinagay ko na lang yan kasi wala rin naman yung ano no? Parang inunahan na natin yung intercept. No? But it's okay for you not to put that. And you still get the same. This is practically zero. So finorce lang natin na huwag na isama yung intercept because we know, okay, thank you Jaime for that question. Because we know that it will be zero anyway. So ganun guys pag ano pag standardize, you will not get an intercept. If ever you get it guys, zero yan. Zero. So dito linagay na lang natin. So that as we observed a while ago, wala, no? Wala. Automatically tinatanggal na lang natin yung intercept. Okay. So okay, let's now go to quadratics. No? But there are sometimes the value will call for a particular variable to be squared or to be either squared or cubed. So depende yun sa ano, sa model natin. Okay? So let's have a simple example. Okay, let's use the same data. Tapos ang gawin natin, si rooms is square natin, no? So we're going to regress the price. We're going to regress it on NOx, distance, rooms, room squared, and ST, student-teacher ratio. Okay, so let's do that. Okay, so we have, let's call this mod, mod underscore Q na lang, no? Quadratic. Okay, you can name it any way you want. So LM, let's regress price. So saan natin siya i-regress? Kay NOx plus kay distance plus rooms. And then, paano si rooms? Paano si rooms squared, guys? Can we do this? Rooms squared and then plus ST ratio. And data still is equal to that one, no? Tama ba? H price pero that okay. H price 2 or that one? The same. Okay, sorry about that. Dito ginamit ko H price 2, which is just the same as that one. Okay, so let's summarize this. Let's get the output summary ng mod Q. Okay, will this run? No, hindi pwede, no? Kasi dito tayo nagta-transform sa ano sa dependent variable. So this has to be I. No? Dapat may I yan. Right? So we're squaring the rooms. So we know that this should be in an integration parameter. No? All right, so let's run this. Wait, ano nangyari? LM. So what happened? Data must be a data frame. Okay. Tingnan ko ba itong that one na to? Do I have it here? Let me check. Sorry. Hindi ba si that one? Hindi ko pa pala na-run. Apologies. I didn't run this. Sorry. Anyway, H price 2 na lang para hindi ko na i-run. Pareho lang naman yun. H price 2. Hindi ko pa pala na siya na-run. That one kanina. Alright, so let's run this. Okay, so yun, no? Okay, so meron na tayong ano, no? We now have this we now have this rooms squared. Okay, so that's how we modify our variables in either as a dependent variable or an independent variable. Okay, pwede rin, aside from this, meron pang ibang way. And for me, I prefer this way. So copy natin to. Control C, Control V. I'll just call it Q1. Lagyan natin mo. Okay, instead of using I, okay, pwede natin gawing ano? Pwede natin itong gawing poly. No? So the poly function, ano natin para so you know what this does. No? Polynomial, right here. So this is from the stats package. Right. Returns or evaluates orthogonal polynomials of degree 1 to degree over the specified set of points. Okay, so don't bother about the orthogonal. So anong gagawin itong polynomial function na to, class? Okay, i-introduce niya yung ano yung i-introduce niya yung number of degrees, no? So ito kasi 2 degrees tayo, no? We have rooms at saka room squared. So what will happen is that you can erase, delete mo yung rooms, tapos i-define natin polynomial rooms, okay? Tapos ilang degrees? 2. And then we include row is equal to so andi dito yung row is equal to 2, ano? Okay, kasi it has something to do with yung orthogonals. Okay, we don't want orthogonal polynomials. Pero hindi ko na-explain kung ano yung orthogonal. Okay, we just don't want this to be converted into orthogonal polynomials. Okay, so we have this Lm price regression Knox plus distance, and then instead of spelling ko, instead of using rooms plus I room squared, we can use the simplified poly. Okay, si rooms o polynomial natin and to the power 2. So ibig sabihin may rooms to the first and rooms to the second. Okay? Class clear ba to?
Yes, sir.
So we change rooms at saka room squared into poly. The advantage of this is that you can have, for example, if kasama pa si cube to the third power to the fourth power. So dadami yun, di ba? I rooms cube, then rooms to the fourth. Ito, rooms lang, poly lang, and then it changes with 4. So it will generate rooms, room squared, rooms cubed, rooms fourth to the fourth. Okay, if it's the fourth power. Okay, so let's run this. You'll get the same answer. Yun din, no? Ang ilalabas nga dito sa regression natin, poly 1. What's poly 1? This is rooms. No? Poly 2. This is rooms squared. Let's compare with this one. Yan. Okay. All right. Sometimes we're not interested in the, especially if the values are quite big. dito sa H price nito, price 24,000, 21,000. Sometimes we're more interested in getting the log. Okay, especially sa finance, minsan malalaki yung mga values, GNP, GDP, and it will be better to look at it in terms of logarithms. Ito may linagay na log, no? So, log linagay na niya. Pero we're not going to use this. Ilolog natin mismo yung model natin. Okay, so how do we now model it in such a way that we're looking at the logarithms of the variables natin? So let's call this mod log. L na lang. Okay, and then LM. Tapos ilog natin si price. Okay, and then regress on. Okay, copy na lang natin to. Nox distance. So, copy natin to. So, log ng Nox. If you take a look at this, Nox is, hindi mo masyado malaki Nox. You can get the log of distance also. But here, let's just limit the log, no? Log ng price, tsaka log ng Nox. So na ako. Iba pala to. Sorry. Ibang subject. So let's just limit it to log. Pwede rin natin gawin log, no? Ito, itong distance. But I'll not do that anymore. Okay, so this is small L. Gawin space dito. Log price, regress on log Nox plus distance plus poly plus the student teacher ratio. Let's run this. Okay, saan ako ito, dalawa. Run. Okay. All right, you can see now that the values here are pretty smaller compared to the other one. Yung absolute figures yung ginamit natin dito, di ba? Ang laki ng mga values natin dito. Dito, okay, naka-scale na siya. You can see here that, okay, itong mga, yung iba, yung linog natin, si Nox linog natin, si distance hindi. Okay. Okay, so the question is, how do you interpret this? Okay, I'll just, you have to research this, guys. Pero di ba sinabi ko magbibigay pala ako ng Word file. Hindi ko pa pala nagawa yun. Sorry guys, medyo ano lang talaga yung schedule. My apologies for that. Tsaka, I tried looking, actually sa totoo lang din, I couldn't find the file, no? I tried looking for it yesterday. Hindi ko makita. When I couldn't find it, I stopped muna. And then I tried looking for it again kanina. Still, I was unsuccessful. Siguro it's in one of my USB na hahanapin ko pa. No? But I want us kasi to know how to interpret this. The price is in log. And then there are some variables that are in log and some that are not. No? So how do we interpret kung nakalog yung dependent, kung nakalog yung nakalog tong independent, pero yung dependent hindi nakalog. So I'm just going to discuss pag parehong nakalog, that's the easiest to discuss, no? Okay? Pag yung isa naman nakalog, yung isa hindi. So there's also a way to do that. Alam natin kung parehong hindi nakalog, straightforward lang. Straightforward. So dito, since the dependent variable is log, so medyo mag-iiba yung pag-interpret natin ito, no? Okay, medyo maiiba. Kasi naka-log si independent dependent variable, I mean. Okay, if both are log price and log NOx, how will you interpret this? You will interpret this as for every 1% increase in NOx, there's a corresponding 0.97% decrease in the price, okay, ceteris paribus. Reading ko, for every 1%, kasi nakalog si NOx, ang change nito will be in percent. For every 1% change in NOx. Dati, kung walang log, for every 1 unit. Okay? Pag nakalog siya, for every 1% change, for every 1% increase in NOx, there's a corresponding 0.98% din. Percent. Bakit ko pina-percent din? Kasi nakalog din sa price. So every time na may ano dyan, na may dinalog, percent ang pag-interpret natin dyan. For every 1% increase in NOx, there's a corresponding 0.976% decrease in the average price, ceteris paribus. So percent ang pinag-uusapan. Okay, now try to see how do we now interpret this. Yung distance, hindi siya nakalog, pero si price nakalog. Okay, so how do you do that? Right? So let me leave that up to you first to try to explore. Tapos paano naman kung yung, let's say, the dependent variable is not log, no? Tapos si independent variable nakalog. Dito kasi si independent variable hindi nakalog, si dependent variable logged siya. Okay? So try to explore that. All right. So ano tayo ng log dito, no? We attempted to look at kung nakalog naman, and when you do usually use log class, in particular if the values are quite big, so medyo mahirap i-handle, mas mahirap i-interpret, and sometimes there are variables na talagang dapat linolog siya. Kunyari, returns usually what we get is the log returns. Okay, any questions so far, class? Clear ba so far? Okay, good. Okay, so one important question here is to ask, may contribution ba yung mga additional variables na to in explaining our dependent variable price? That's a valid question, di ba? Will, for example, si distance ba? Does it have a statistically significant explanatory power dun sa regression model natin with all the other variables? Si rooms. Okay? Si rooms, may ano ba siya? May explanatory power? Or, di ba, last time, sa ano natin, what we did was to define what an unrestricted model is and a restricted model. Kasi yung restricted model, siya yung lesser yung regressors natin. Si unrestricted, siya yung mas maraming regressors. Diba? And if you recall, dun sa ANOVA natin, analysis of variance between an unrestricted, restricted and unrestricted, ang null hypothesis natin doon is ano yung null hypothesis natin? Because, guys, the restricted model ba o unrestricted model is better? Diba? The restricted model, diba? Yung null hypothesis natin doon, the restricted model is preferred over the unrestricted. Ibig sabihin nun, there's no point in adding another variable because it will not contribute to explaining your dependent variable. Okay, so we have seen that before. Gumamit tayo ng ng ANOVA, no? Dito, pwede din natin gawin yon. Okay? And then we can make use of merong linear hypothesis na, let's see. There's a function called linear hypothesis. I think this is coming from hypothesis. So, pwede natin gamitin to para ma-check kung may ano ba, kung may contribution ba. Oops. Ba yung spelling ko? Linear hypothesis. Ay, mali. Kalimutan ko yung question mark. Question mark. Yeah, this is from the car package. So this is a generic function for testing a linear hypothesis and methods for linear models, GLMs, multivariate, etc. Okay, so ano ginagawa nito? And dito yung syntax. Maraming klase, no? Maraming klaseng linear hypothesis, but we'll just limit ourselves to looking at yung effect ng mga variables natin. Okay, so here, let's check, no? Let's use this model para malaman natin kung may effect ba itong si poly 1 and poly 2, the rooms 1 and rooms 2. Kasi itong poly, di ba, gagawin niyang polynomial. Ilang power 2, ibig sabihin, si rooms to the first power, at si rooms to the second power. So, dalawa, no? So, if we take a look at our output, so this is your beta 1, beta 2, beta 3, beta 4. So, we're interested in this. Si beta 3 and beta 4. No? Kaya yan ang gusto natin malaman kung nakakaano ba siya, nakakatulong ba siya dun sa ano, sa pag-explain ng dependent variable natin. All right? So what we can do is we can use that. This is coming from the car package, diba? So this is linear, linear defunct na to, no? Dati, wait. Defunct dito. Ito linear dot hypothesis small h. This is already defunct, no? Wala na siya. So ito linear hypothesis. Okay? So coming from your mod L, your linear model, ito yung linear model natin. Diba? Ito yung, andito si beta 3 at saka si beta 4. Okay, we would like to test. Okay, we can use the match. Okay, match coef. I'm trying to recall. At hindi lumalabas. No? Match small c ba yun? Okay. I know it's big C. Anyway, match coefs. Okay. So, i-match natin yung coefficients from the okay, from the match coefficients. Yeah, mod L. Okay, and then rooms. Okay, rooms. So yung rooms, dalawa yan, no? Yung first power at saka second power. Okay, let's see what happens. Oops. Ano nangyari? Mod L. Hindi na ba yung match? Ano? Check ko nga, class. Pero wala dito eh. Check sa Google. Ang aking default pag I used to use this. O meron naman, no? Bakit wala? Bakit hindi siya match coefs? Okay. So which means that, so this is the, okay. Binago ng syntax. Plot. So dapat yung mukhang class nasa ano na siya, no? Nasa coef plot na package. So okay, matagal ko na kasi hindi nagamit to eh. Let me see. Install ko nga sandali si ano. Okay, install nga class si ano. Ay, time na pala, no? Yeah, guys, just 1 minute, ha? Install that package. Just very sorry about this. Ano lang natin to kasi mabibitin tayo dito sa ano. Coef, ano yun? Coef plot. Okay, so it's coming from yun ba? Coef plot, ano? Coef plot. Sige. Sorry guys, ha? Ito lang, install that packages, coef plot. I hope 1 minute lang siya. Okay, tapos, alright, i-library natin para magamit natin. Coef plot. Okay, so let's see if this will run now. Kasi naka-install na yung si coef plot kung saan nanggaling si ano. Sulat nga natin to kung lalabas na. Match. Wala pa rin. Hindi pa rin lumalabas yung match coef. Error pa rin. Okay, so let me stop there. Let me check this class. See, I used this before. Ginagamit ko to eh. Tanggalin ko tong si car. Wala pa rin. So hahanapin ko tong match coef nito. Pag dito lang, match coef. Karon siya eh. Match coef. Check this. Ayaw. Okay, anyway, so stop recording. I'd like to stop